Okay, so let's suppose here we had some function of x and y. So that's some surface like this. And then I want to figure out the surface area of this thing, right? So the way I'd kind of try to like start approximating a surface area, right, is that it's, well, if I think about a little patch in here, right, here's some little patch. That's like a delta x by a delta y down there, yeah? And then if I come up here and I think about the little patch up here, that's probably some little curvy patch, right? And I want to know the surface area of that thing. So here at this corner, I've got some vectors that I think I know about. So I've got my funny little curvy patch here, right? And I've got these two vectors that I know about. Those are going to be kind of related to fx and fy. So this vector here is 1 in the x direction, 0 in the y direction, and then the value of fx at x naught, comma, y naught in the z direction. Really that's because this value, right, is going to give you the rise per 1 run in the x. So if you go over 1 in the x, you get about that in the y. Or, sorry, about that in the z. And then this other guy is going to be given by the vector 0, 1, and fy at x naught, comma, y naught. Right? And then this funny little curvy patch, well, the deal is that its surface area is about the same as the area of this parallelogram here. And you might remember the way you get the area of a parallelogram is you take the magnitude of a cross product. So, I think the surface area is going to be basically the sum of the magnitude of fx crossed with, well, fx and fy aren't vectors, right? So it's going to be the cross product of 1, 0, fx crossed with 0, 1, fy. Right? So I'm going to have to go get all of those from someplace. And if I calculate this cross product and then take a limit, you get this idea that you need to double integrate over a and b in the x's and c and d in the y's. Some kind of, well, it ends up being the square root of 1 plus fx squared plus fy squared d, well, and I'll just write dx dy. Cool. So this is a formula you can use. Really where this comes from is this thing is the magnitude of this vector. And then change in x, change in y are the limits as you push everything towards 0. So you can go ahead and use this formula if you want. And again, the bounds here don't need to be constant. This does need to be in terms of x and y. You can, after you've figured out what this stuff is, then you can convert to polar. But don't mistake this for fr and f theta. Those don't work quite this way. You could figure out a similar thing, but it doesn't work quite this way.